So graph each parabola, identify the vertex, the y-intercept, the axis of symmetry, and make a table of values. So if I'm looking at this parabola, I'm just going to talk about some facts about this parabola based on the equation. So I know that this parabola opens up because the coefficient of x squared is positive. I know that it's narrow, it's a vertical stretch because a is greater than 1. I also know the y-intercept is -5. So I'm going to find the vertex and do opposite b over 2a. So if I look, there's not a b term, so b is 0. So it's going to be 0, plug in 0 for x, and you get -5. So the vertex is right here, and it opens up. So to make a table, I'm going to plug in 0, -5 in the middle of my table, and plug in numbers greater than or less than. So if I plug in -1, it's going to be -5 plus 3 times -1 squared. So that's going to be -2. And symmetry is going to be -2 on this side. So now I'm going to plug in 2, and it's going to be -5 plus 3 times 2 squared. So that's 4 times 3 is 12, minus 5 is 7. So here are my plots, -1, -2, and these -2, 7, and are way up here. So I knew it was going to be narrow. So my axis of symmetry is always an equation. So x equals 0 is my axis of symmetry. My y-intercept is 0, -5. So I'm going to do the same thing over here. When I do an opposite b over 2a, I get 0, plug it in, I get -4. When you're graphing and you're making a table of values, always put the vertex in the middle. Pick numbers that are less. And then I'm going to plug in -1. So when I get -2, which means 1 has to be -2 because of symmetry. And I plug in 2. So this is 4 and 4. So I plot the y-intercept is 0, -4. And 2, 4, -2, 4. So both of these parabolas open up because A is positive. Both of them have negative y-intercepts. And they both have axes of symmetry at x equals 0. So this slide just goes over kind of what I said about whether it opens up or down, how to find the axis of symmetry, how to find the vertex, both points. The y-intercept has to be the c value, and you can use the axis of symmetry to find other points on your parabola. So if you know this is a point over here, this has to be equal distance, this works. Graph each function, label the vertex and axis of symmetry. So to find the vertex, remember you do opposite b over 2a. That's your x value, and then you're going to plug in -b over 2a to see what your y value is. So for a, to do the vertex, I'm going to erase this. So it's opposite of 4. So it's -4 over 2 times -1. So that's a negative right there. So -4 divided by -2 is 2. So that is my x value. And I'm going to plug my x value in. So it's going to be the opposite of 2 squared plus 4 times 2 plus 2. So be really careful with this negative right here. You're going to do x squared first and take the opposite of it. So even if this was a negative number that you're plugging in, negative something squared is going to be a positive, and take the opposite of it. So when you plug in 2, you get -4 plus 8 is 4, plus 2 is 6. So the axis of symmetry has to be the equation x equals 2. So when you make a table, you can put 2, 6 in the middle, so over 2 up 6. And then the y-intercept is 2. Now, if this is my line of symmetry, x equals 2, and I have my y-intercept, I know that another point over here has to be over here. So that's what my graph looks like. So I'm not really making a whole table. I'm using the point for the vertex and then what the y-intercept is, and then putting the point across from the y-intercept. So I'll do another one. So negative b, so it's 2 divided by 2a. So it's 2 times negative 1/3. So these 2's are going to cancel out, and then if dividing by negative 1/3 is the same thing as multiplying by negative 3. So dividing 1 by negative 1/3 is the same thing as doing 1 times negative 3, because when you divide fractions, you multiply by the reciprocal. So the vertex is going to be at negative 3, and then I'm going to plug in negative 3. So it's going to be negative 1/3 times negative 3 squared minus 2 times negative 3 minus 3. So negative 3 squared is a positive 9. So negative 1/3 of 9 is negative 3, plus 6 is 3, and then minus 3 is 0. So the vertex is at negative 3, 0. So I'm going to go to negative 3, 0. That's my vertex. And this is opening down, and the y-intercept is negative 3. So this is my vertex, and my axis of symmetry is the equation x equals negative 3. So I can use my axis of symmetry as a line of symmetry. So that means this point has to be over here. And now I can make my parabola. It's wide and it opens down. And then a couple word problems using the maximum and minimum, which is another name, which is a vertex. A company knows that negative 2.5p plus 500 models the number it sells per month of a certain make of a unicycle, where the price P can be set as low as 70 or as high as 120. Revenue from sales is the product of the price and the numbers sold. So what price maximizes the revenue? So if we want to maximize the revenue, we have to find the vertex of the revenue function. So if I look at this line, it reads revenue from sales is the product, so that means multiply, the price and the number sold. P is the price, so I'm going to multiply P times the number sold. This expression right here models the number it sells, so that's the number sold. So it's going to be P times negative 2.5P plus 500. So this is the tricky part, coming up with the revenue function. So I'm going to distribute this, so it's going to be negative 2.5P squared plus 500P. So the first question reads, what price will maximize the revenue? So if you think about this function being a parabola, it's a parabola that has a y-intercept of 0 and it opens down. This right here is going to be, the x value is going to be the price that maximizes the revenue, and the y value is going to be the maximum revenue, the highest money that you're gonna bring in. So I'm going to do the vertex, because maximum is a keyword for vertex, so I'm going to do opposite b over 2a. And I'm going to get negative 500 over 2 times negative 2.5. So that's negative 500 divided by negative 5, so it's 100. So the price should be, you should set the price at $100 for a unicycle, which makes sense because the problem up here is as low as 70 or as high as 20, so 100 fits in between the two. Then what is the maximum revenue? You're going to plug in 100 back in for P. And I ran out of room, but you can plug in 100 back in for P to see what the maximum revenue is. And then down here, you're going to do the same thing. What price will maximize the revenue? So we have P is the price of the widget, and this is the number of widgets sold, so you're going to do P times negative 5P plus 100 is equal to R. So R equals negative 5P squared plus 100P. So I want you to figure out what the vertex is of this, what is the vertex of the P value, which is the same thing as X, and then plug P back in to get the revenue. So you're going to have an ordered pair.